Hello, everyone. Thanks for attending today's webinar on the topic of RF antennas. So for those of you who don't know, my name is Harry Finch, and I'm Siretta's Antenna Product Manager, and I look after our range of RF antennas, cables, and RF accessories. So before we start this webinar, can I ask if everyone could please make sure that their microphones are muted and their cameras are turned off just to save bandwidth? And I'll do the same as well once we start the presentation. If you have any questions, please enter them into the chat and someone in our team will either answer it straight away, or if your question's a bit more complex and needs a bit longer to explain, then do still put them in the chat. I don't know if there'll be time to answer questions at the end because every time I do this presentation, I end up overrunning, as there's always so much to discuss with this topic. But if I don't have time to get your questions, then don't worry, we'll collect them all at the end of the session and answer in detail in a follow-up email. And that will also include a copy of this presentation and some useful links to some of the things that we'll talk about today. Okay, so I'm going to turn my camera off now. Okay, so let's see, what's on the agenda today? Well, essentially, I want to give you all a rundown of the basics when it comes to selecting a Siretta antenna. So you salespeople in the call will likely often have a customer ask you for an antenna recommendation for their application, and with the information in these slides, you should be able to do that no problem. Many of you will already be experienced in doing this, but I hope you can still learn something new today, and if not, maybe it will just refresh your memory. And for you marketing people in the call, this information, will give you a good solid understanding of the core features and benefits of our antenna range. And hopefully you'll be well equipped to position these products accurately in campaigns and social media posts and things like that. If you're an engineer in this call, then apologies in advance. We're starting this webinar series with a high-level basic overview of antenna selection. But if you'd like a webinar in the future that goes into great technical detail on some of these topics, there will be a QR code to a feedback form at the end. So, feel free to let us know what topics you'd like, and we can do that in the future. So, antenna selection. How do we recommend the right antenna to our customer that will give them the best performance possible? Well, the first thing is that no two applications are the same, right? There's no one-size-fits-all solution. An off-the-shelf product might be, but very often we need to guide the customer towards a solution that best serves their needs, right? Something as simple as just customizing the cable length to minimize signal loss. And that's why we do so much customization at Siretta. Applications that your customers come to us with should have a unique antenna to match, that's optimized for that specific device, that specific environment that it will be placed in. Because at the end of the day, if the antenna performance is not optimized, then the device that it's connected to won't be able to transmit data consistently. So we basically need to dig deep into what our customer is doing when we get that initial inquiry for like a 4G antenna. We need to ask lots of questions and understand the unique requirements of that application. And many customers that come to us, they don't know much about antennas and connectivity. They're experts in their but they need guidance on the RF side of things. Should they use an omnidirectional or a directional one? What level of gain do they need? How will they mount the antenna? And we need to be there to confidently give them those answers. So these are the factors that we'll look at. It's a bit like a sort of checklist. So we'll look at the mounting type, the technology and the frequency range associated with that technology, the directionality and the gain, and finally the environment that that antenna will be placed in. So mounting types. Many of you will already be aware of Siretta's 6 categories, as it's usually covered in Jade's onboarding training. But for those of you that might be newcomers, or those of you who may want a refresher, I'll just outline them here. So Siretta's range is split into 6 groups based on how they're physically mounted, because we found that the first thing that customers are interested in during that antenna selection process is how they're actually going to attach this thing mechanically. So we use the phonetic alphabet, like Alpha, Bravo, Charlie, and so on, to name each antenna. And then we assign a sequential number to each new antenna released in that mounting type. So our first antenna in the Tango or through-hole mounted range was the Tango 1, then the Tango 2, and the Tango 3, and so on. And now we're up to the Tango 58. And you can look out for this blue icon on the data sheet here on the left, if you're ever unsure of the mounting type for the antenna that you're looking at. So in alphabetical order, the alpha ranges first. As you can see from the slide, the alphas are the adhesive mounted category, and they're designed to stick directly to surfaces using a pressure sensitive double-sided tape. So you peel off the liner, you stick it to your chosen surface, and it's as easy as that. This is a very popular option for applications where quick installation is key, and it's intended for use on flat plastic or glass surfaces, like inside cabinets or kiosks or indoor enclosures, that kind of thing. The main advantage here is the convenience. They're quick to deploy, they don't need any drilling or special tools. But on the other hand, they're generally not suitable for outdoor environments, especially where you have things like high moisture, UV, temperature extremes, because those adhesives can degrade over time in those conditions. Now you can customize with us for a specific type of adhesive that can be used in more extreme outdoor conditions. But we found that this type of adhesive needs longer cure times and is more complex to install. So you do lose a bit of that convenience that makes the alpha category attractive in the first place. Direct connect or delta antennas, as the name suggests, you plug these straight into the RF port of a device like a modem or a router or a gateway, or even a handheld device like the Sniper. So those 2 antennas on the Sniper 5G are delta antennas that we specifically designed to be able to work on every key global 5G and IoT band. And it was so good that we wanted to release it on its own, and that's the Delta 47, which is actually one of our most popular antennas this year in terms of volume sales. But anyway, the benefit of these is that they're compact and efficient. They have low insertion loss since there's no cable involved, right? However, they're typically not ideal if the device is public facing because of the risk of the antenna being knocked off or possibly even vandalized. They also usually aren't IP rated and not designed for outdoor use, although we have just released a new range of IP67 rated deltas, because there are those customers who absolutely need this mounting type for outdoor use. But generally speaking, it would be better to go with a Tango through-hole mount or an Oscar, an outdoor antenna. So typically deltas come with an SMA connector, and other connector types are available through customization. But one little thing to remember is oftentimes delta antennas that are designed for Wi-Fi will have a reverse polarity SMA connector, where the male pin and female basket have been reversed. And the reason for this is a long story, but just be careful essentially about this distinction. If a customer has a Wi-Fi application and asks for an SMA, you can show them this comparison chart here on the screen to check if they really mean reverse polarity SMA. So the echo range, these are embedded antennas that are installed internally, either directly on the PCB or within the housing of the product. This is great when you want a clean look to your device with no external parts sticking out, which is something that modern product designers are leaning into more and more. So they're also great when space and weight are a limiting factor, like with drones, trackers, compact sensor nodes, and things like that. For example, these black FPC antennas that you see here on the top right of the screen that we released last year, these are less than 1 millimeter thick. They weigh less than a gram, and you get great performance out of them. And you can bend them and stick them on curved surfaces without compromising the performance, and they cost less than £1. So there are great benefits to the Echo range. However, like everything, there are always trade-offs and disadvantages to consider. Because they're often so small and enclosed in the device, you're probably going to struggle to get as good an RF performance out of them compared to an externally mounted antenna. Plus, it will likely be placed near other circuitry, which can affect the performance through interference and detuning. So you do need careful RF design to make sure that you get good matching and efficiency. So, while it's neat and tamper resistant and lightweight and all of that good stuff, it does add complexity to the engineering side. However, we have, in order to help customers with this challenge, we've developed a useful app note that gives some guidance on this topic. So I've added some screenshots here. It shows, best practice for installation, how to properly mate the mini coax connector to the module. So if anyone here has ever tried to mate, for example, like an IPEX MHF4 connector to a module, you'll know how tricky it can be, even if you have the special tool that you can get. And it comes with the answer to other challenges, like how to contend with the issue of antenna polarization in relation to the mounting of the antenna inside your enclosure. So I've got a link there at the bottom, and you can have a read of that or send it to a customer if they ever need help on the integration side. So magnetic mounted mic antennas, right? These come with a built-in magnet, and they're made to attach quickly to metal surfaces, commonly used on vehicles or industrial machinery where a temporary or a flexible placement is helpful. They're very easy to install and reposition, and they're great for test environments and mobile setups. However, they're not that well suited for high vibration environments, and just like the deltas, the direct connect types, they can be vulnerable to vandalization and theft as well if the equipment is accessible to the public. Tango through-hole mounted antennas. So these are physically bolted through the mounting surface. So that could be the roof of a cabinet or a vehicle, or just your typical industrial enclosure. It could also be on things like smart parcel lockers, kiosks, vending machines, parking meters, and of course, EV charging stations, which is a big one for our Tango range. So anything that's public facing and needs to take a payment or send data wirelessly, then through-hole mounted antennas are really the best option. It's by far the most secure mounting method, and vandalism is surprisingly common. A tall whip style mag mount antenna, to some people, they just can't resist snapping it off, and once it gets ripped off, that's it. You've lost your connectivity, the device is down. Your end users will simply look for a different machine, and that can have a real effect on your customers' revenue, essentially. So the more low profile, or in other words, the smaller height of the antenna, the better. We're actually developing a new 5G and GPS Tango 2-port antenna specifically for public EV charging. And it's the one you can see there on the left of the screen. And this one is so low profile that, first of all, you can't really get a grip on it to if someone did want to vandalize it, right? And second of all, people don't even realize it's an antenna. They just think it's a bolt cover or part of the enclosure. And honestly, that's the best way to prevent vandalism, is when the antenna doesn't even look like something worth touching. And of course, these antennas are normally designed for outdoor as well as indoor use, and they'll tend to have some sort of ingress protection rating, like IP65 or IP67, depending on the model. The disadvantages or trade-offs here is that it does take a bit more effort to install. You'll need to drill a hole. You'll need to make sure there's proper sealing around the base. You'll need access to the inside of the enclosure to tighten the hardware from underneath, which can sometimes be a bit tricky. But once it's in, it's solid. You've got secure mounting, weatherproofing, and that's something that's going to last long term in the field. So finally, our Oscar range, which stands for outdoor antennas. These are mounted using brackets or clamps, typically on external walls or poles, and they're essentially good for when you need line of sight or broader area coverage. And this category includes things like panel antennas, omnidirectional antennas, directional Yagis, and LPDA antennas. And this category will give you the best performance, right? So they're bigger than the other mounting types. They're designed to transmit and receive signals from further away. Plus, when you're mounting an antenna externally instead of internally, that's really the best way to improve signal in cellular applications, especially because now the signal doesn't have to try and penetrate these attenuating obstacles like a brick wall. And if you've got line of sight, if you've got the antenna nice and high up on a pole, that's when you start to see real improvement in the signal. But it does require planning and setup, particularly with the cabling and the waterproofing, and sometimes you might even want to consider lightning protection. So while the performance can be excellent, it is a bit more of a commitment in terms of installation time and resources. But for those Oscar antennas that are a bit complex to set up, we have redesigned the packaging to include a QR code, and that links to an installation guide. And that installation guide sort of covers everything you need to know to set up the antenna. What's included in the box, what tools you'll need, the best practice for installation, including things like the recommended torque for fastening the nuts and so on. And we've done them in a sort of IKEA style to make them easy to read, and hopefully this can make installation easier and takes away some of the guesswork for your customers. So there you have it. There's a little summary of the different mounting types. Each one has its place. The right choice kind of depends on the environment, the level of access, the mechanical needs and performance requirements of the customer. So hopefully this breakdown can help when you're specifying or recommending antennas for your customers' applications. Now, antenna form factors are another way of describing the antenna that you may see in our data sheets. Here's a list of some of the main types that you'll tend to see, although there are many others. And I don't think we have time to dive into the details too much here, but I will be writing a blog on this topic in the near future, so you can keep an eye out for that when it comes out. But we'll quickly run through these. So the first one is the dipole. This is kind of the most fundamental of the antenna types, and it's a balanced two-element structure where current flows in opposite directions in each arm, and it radiates in a sort of donut-shaped pattern, which basically means it's omnidirectional in the horizontal plane. Then you have the whip antenna. So this is essentially a monopole. It's a single radiating element over a ground plane, and it acts as a quarter wave radiator. And that just means there's a bit of copper wire inside that's been cut and tuned to be 1/4 of the wavelength of the target frequency, which helps it resonate efficiently with the signal. Then we have patch antennas. So this category includes your ceramic GPS patches and your PCB-based cellular or Wi-Fi patches. And these are flat, sort of conductive elements mounted over a ground plane that forms a resonant cavity. Then we have the puck antenna. So you'll recognize this style. It's low profile, sort of a dome that houses one or maybe multiple sort of internal elements, usually a combination of antennas inside, like maybe a PCB for cellular and a ceramic patch for GPS. And they're soldered to two separate cables, and you can have multiple technologies covered by the same antenna, and you only have to drill one hole. And you can have it be through-hole mounted, like the image here on the right, or adhesively mounted with a radial exit lead coming out of the side, like on the left. And then finally, we have the panel antennas, the Yagis, the LPDAs, the log periodic dipole array antennas. And these are the directional types, typically used for building to building or industrial communications. They offer a good mix of directionality and coverage, and you have gains of anywhere between 6 to 14 dBi and beam widths from anywhere between 15 and 90 degrees. Okay, so now we have our we know what our customer needs in terms of mounting the antenna and maybe what sort of form factor they're likely after. So we now need to consider the technology and the frequency requirements of the antenna, right? So when it comes to IoT connectivity, Siretta has a really big range of antennas to support all of the key communication technologies that are in the space today. And again, you can look out for these blue tags on any Siretta antenna datasheet to see if the technology you're looking for appears. We've got a great range of cellular antennas from legacy 2G all the way up to 5G that also cover Cat-M and NB-IoT frequencies. We have antennas for LPWAN tech like LoRaWAN and Sigfox that enable that sort of long-range, low-power communication. We have Bluetooth and Zigbee antennas for reliable short-range links. And we've got Wi-Fi antennas all the way from Wi-Fi 4 right through to the newest iteration, Wi-Fi 7, for faster and higher throughput data connections. And of course, we have GPS or GNSS antennas for precise and reliable global positioning. And we have antennas that combine multiple technologies, right? As well as MIMO antennas that are designed for higher throughput. And of course, we're always looking ahead as well and actively looking for the next wave of communication needs. And that's why we're currently developing a range of non-terrestrial network or NTN antennas to support the satellite-based IoT that's going to extend coverage where ground networks can't reach. Now, one thing that's important to clarify is that antennas themselves, they're not intelligent components, right? They don't process data. They don't know what protocol is being used. They're just simply tuned pieces of hardware. So what makes an antenna work well is that it's matched to the frequency of the technology. When that's done correctly, you get the right polarization, gain pattern, low VSWR, and that means you'll have more efficient energy transfer and better performance. So, for example, an antenna tuned for 868 megahertz could be used for both LoRaWAN and Sigfox because the technologies share the same frequency band. The same logic would apply for 2.4 gigahertz there. One antenna could serve Wi-Fi, Bluetooth, or Zigbee just fine. And to prove my point, I have a slide here that kind of shows a test that was done by our test lab that we partner with for antenna validation. So they have kind of a fun contest where people can submit silly antennas, and if you guess the gain, then you win a prize. So you can see here that someone submitted a baguette antenna with a copper strip wrapped around in a helix shape, which they tested in their anechoic chamber. Now, a baguette, as I'm sure we can all agree, is not a conventional substrate for antenna design, but if the copper is shaped and sized correctly and the resonant frequency is right, then it actually can radiate efficiently. And in this case, this antenna achieved a gain of 7.5 dBi in the GPS L1 band, right? And that's a better gain than many commercial compact GPS antennas that are out there on the market. Now, obviously, this antenna wouldn't last very long in a real world scenario, but it just proves that antennas are not technology aware, they're not smart devices, they're just governed by physical geometry and frequency tuning. The material could, it could be PCB, ceramic, plastic, or a baguette. As long as it supports the correct electromagnetic behavior, it can function as an antenna. So it's not about the technology when it comes to antennas so much as it is about the frequency. So hopefully I've made my point with that example. If you're ever unsure which antenna works for which frequency, most of you will be aware of this already, but our data sheets have a traffic light system to make things easier. If the VSWR is low enough in both the uplink and downlink for that band or frequency range, and if the radiation efficiency is above a certain level, and the gain pattern is such that the antenna is usable in the real world, then we'll highlight it green and you can safely recommend it to your customer for that frequency or technology. So on the left here, we have what we call a spectral view diagram. And you can usually find this on page 4 of our antenna data sheets. And this is a sort of quick overview of the antenna's performance across the entire frequency range that's typically associated with IoT, which is around 400 megahertz to 6,000 megahertz. Sometimes we go up to 8 gigahertz just to show the performance for Wi-Fi 7 and some other emerging 5G bands that are up there. And this thing just shows the key frequencies and the associated technologies with green, red, or amber. So on the left here, you can see that this is for an antenna that's designed for Wi-Fi 6. So it needs to work on the 2.4 and 5 gigahertz bands, which it does. But it also happens to cover many cellular bands in that 1800 to 6000 megahertz range. So if, for example, you were only interested in the 5G C band of 3.3 to 4.2 gigahertz, those popular bands, N77 and N78, then this antenna would be perfectly suitable for that technology. So then on the right here, you have the same traffic light information, but broken down for every cellular and non-cellular band. And we're always adding new bands as they emerge and republishing the datasheet. So if you want the newest version of any datasheet for your website, you can download it. You can download it from our website, or there should be a monthly automated email from our Siretta portal that notifies you which datasheets have been updated. We've also put this cellular band information into a new selector tool, which I'll show you at the end of the presentation. So going back to our selection checklist. So we now know how our customer will mount the antenna, and we know the technology and frequency requirements, right? So now we need to consider the directionality and gain of the antenna. So this topic can get quite complicated and confusing, so I'm just going to give you a simple way to understand it. So gain is a measure of the antenna's ability to concentrate and direct radio RF energy in a specific direction compared to a theoretical reference antenna that's called an isometric antenna that radiates uniformly in all directions. Now this perfect isometric antenna doesn't actually exist, but it just serves as a baseline to compare real antenna performance. And this measurement is expressed in decibels isometric, or dBi. So let's explore the topic in a bit more detail. So generally speaking, you can divide antennas into two types, right? Directional and omnidirectional. And we're going to use an industry typical analogy here and compare gain to light to make things a bit easier to understand. So a directional antenna works like a torch, right? It focuses RF energy into one direction. You're not generating more energy, you're just concentrating it, which means you can reach further in that direction. On the other hand, on the right there, an omni antenna is more like a light bulb. So it spreads energy evenly in all directions. So you get broader coverage, but maybe not as much range. Then underneath each one, you can see how gain affects that beam shape. So on the left, with the low gain directional, the beam is like 45 degrees wide. But as you increase the gain, that beam narrows down to, let's say, 25 degrees. So you get more range, but less coverage side to side. Omni antennas behave a little bit differently, but the idea is the same. With low gain, the pattern is sort of an apple shape, radiating nicely in all directions, including up and down. But as you increase the gain, it flattens into a pancake or squashed donut shape, which still covers 360 degrees horizontally, but not very much vertically. Now, one idea that I really want to highlight with this slide is that higher gain isn't always better. It just depends entirely on your customer's use case, right? So higher gain gives you longer range, yes, but the beam gets tighter, which means you've got to be more precise with how you aim it. And that's where a tool like the sniper signal analyzer with live scan mode can be really useful. You know, you can see the live signal strength and align the antenna to the strongest tower in real time. And that takes a lot of the guesswork out. For omni antennas, here's another industry typical analogy that you'll often hear. You know, you can think of an omni antenna a bit like a water balloon. You know, the total power is fixed, you know, like the water inside the balloon always contains the same amount. But if you squeeze it from the top and bottom, it bulges out sideways. So you're not adding power, you're just redistributing it. And that's exactly what high gain does. So you push more signal out horizontally, but you lose it above and below. And that might be great if you're placing the antenna in an environment like a flat warehouse or a wide open field. But it's not so great if you're in a multi-story building, let's say, or maybe a mountainous, hilly area. Or if your devices are, you know, moving up and down. So I'll give you one more industry typical example to illustrate, you know, why high gain is not always better. So let's say you put the high gain Omni antenna. Let's say you put that on a container ship, and the high gain antenna is beaming the signal right out towards the coast where the nearest cell tower is. That's great, but only if the water is calm. If the water starts to get rough and the boat starts to tilt, then that flat radiation pattern will also tilt. And now your signal is kind of firing into the water or up into the sky, and you'll lose connection to the tower. So in that example, in that application, a lower gain Omni with a rounder and more forgiving pattern would actually be a better choice. So, higher gain is not always better. All right, so on this slide, we're looking at how to read antenna gain on a typical Siretta datasheet. So we don't just give you a single gain number and leave it at that. What you'll see on page 5 or 6 normally is a graph showing peak gain across frequency from 400 megahertz up to 6 gig, right? So to find the peak gain for your frequency, it's nice and simple. You just go along the x-axis until you reach the frequency you're going to be using. So in this example, we're looking at 2.4 gigahertz for Wi-Fi or Bluetooth. And then you look up the y-axis and see the gain value at that point. So in this example, you can see the peak gain for 2.4 gig is around 5 dBi. You can also look at the standards frequency support table for more detail. These are normally between pages 6 to 11. Now, the thing to remember with that hopefully this slide can illustrate is that the peak gain is just the maximum gain in any direction, right? So while that number is useful, it doesn't tell you the whole story, right? It doesn't tell you where that energy is going. So that's why it's very important that you also check the 2D radiation plots. So these show you how the antenna radiates at different angles in the horizontal and vertical planes. So again, sticking with our 2.4 gigahertz example, yes, you can see the peak gain is 5 dBi. But if you look at the YZ plane here on the top right, you'll see that the vertical lobe is where that gain is actually happening. And that's important because you want to take full advantage of that peak gain. Then you've got to orient the antenna properly, if you want that maximum gain direction facing the device that it's communicating with. So if you're unsure about alignment, again, you can use the Sniper signal analyzer in live scan mode to help fine-tune positioning in real time. That way you're getting the best signal possible and not just relying on static specs. But for those of you that want the full picture as well, we have the 3D radiation plots on our data sheet. So these give you a much better sense of how the antenna radiates overall, not just in 2 planes, but in 3 dimensions. So you can see here that the peak gain is actually very close to the zenith where that black dot is. And you can see on the color key there on the left that the peak gain reading is 5.14 dBi, which matches what's on the frequency table. VSWR and radiation efficiency. So these are concepts that we've touched on already, as these are what's used to determine the green, yellow, or red traffic light system on our data sheets. So that tells you if the antenna works in that band or not. So really, we've done the hard work of reading these graphs and interpreting them for the customer already, but we still like to show this data across the entire frequency range, just in the spirit of full visibility and transparency. We don't just show the parts where the antenna performs well, we show the whole thing. And it's still worth understanding what these performance parameters mean because they're important when you're comparing antennas. And we'll do a little comparison here on the right. So first I'll explain a little bit about what VSWR and radiation efficiency means. So VSWR, or voltage standing wave ratio, that tells you how well matched the antenna is to your device or transmission line. So a low VSWR, ideally below 2, means that you're getting minimal reflected power. So most of the energy is making it to the antenna, essentially. Radiation efficiency tells you how well the antenna converts that accepted power into radiated energy. So how much of it is actually being sent out as RF signal versus being lost as heat or absorbed by the antenna structure or the ground plane. Now, not all manufacturers specify the efficiency, and that can be a problem because you could have a perfect VSWR but terrible efficiency and still end up with a poorly performing antenna because all the power is getting in, it's just being lost internally and not radiated. So we include both on our data sheets and we combine them into that traffic light system so you get a full picture of how the antenna actually behaves at the frequencies that matter to you. So we can look at a sort of example here. Let's imagine that the customer is looking for a through-hole mounted antenna for LoRaWAN, an application in Europe. So we're talking about 868 megahertz in the ISM band. Now we've got two antenna options here, and we can look at the frequency support table in the datasheet to compare them, right? So looking at the second row for both tables, you can see the efficiency for antenna option 1, 52.67, and for option 2, 64.26. So option 2 has a higher efficiency. Maximum VSWR for option 1 is 2.45, but option 2 it's 2.29, which is lower, which is better. So antenna option 2 provides higher efficiency and lower VSWR, so better impedance matching. And if we look at the gain, option 2 has significantly higher peak gain. Now, as we've seen with previous slides, the high peak gain, that could be a good thing or a bad thing, depending on the environment. But with LoRaWAN, where you're normally trying to reach out to devices, like let's say in a field, if it's a smart farming application, or across a wide flat area, then that higher gain in the horizontal plane could actually be a big advantage because it gives you more range without burning extra power, and that's kind of the whole point of low power wide area networks. So that's a typical example of how you would choose a Siretta antenna for a specific application based on a side-by-side comparison of two data sheets. Okay, so now we've narrowed down the customer's requirements and we're almost there, basically. We've picked the mounting type, we have an antenna with a low VSWR, a high radiation efficiency, and the appropriate directionality and level of gain in a specified frequency range, and we're almost ready to make our recommendation to the customer. So there's only one thing left to consider, really, which is the environment that customer's device is going to be placed into. So even the best antenna won't perform very well if it's not matched to the conditions around it. So that's why understanding the deployment environment is important to make sure the antenna will perform reliably over the long term. So you can ask the customer questions like, is the device going to face extreme temperatures? Will it be exposed to moisture or dust or vibration? Is it going to be operating near sources of RF noise or interference? And it's important to ask these questions, if they haven't considered this type of thing, so we can help them make the right choice. So we'll start with operating temperature. So temperature extremes can have quite a significant impact on RF performance, actually, especially in sort of outdoor and industrial environments. Materials can expand and contract, components can degrade faster, and signal behavior can actually change in unexpected ways. So it's important to confirm that the antenna and the device that it's integrated with can handle the full temperature range that it's going to be exposed to, whether that's a freezing cold storage unit or maybe just the heat of a sun-exposed enclosure that's sitting outside. So operating temperatures can be found on page 2 of our data sheets. Usually you'll see something like this, minus 40 to plus 80 or 85 degrees. Now that is a wide industrial grade temperature range. So it covers the vast majority of global indoor and outdoor applications. So unless the customer is doing something very specific or extreme, then -40 to +85 is usually more than sufficient. But of course, if they do need a wider operating temp, then we can always use a special grade plastic and adhesives that can withstand those temperatures. Right, so now let's have a look at IP rating, which has come up a few times already in this webinar. But for those who might not know, when we're talking about IP ratings, we're talking about ingress protection, or how well the antenna can withstand dust and water getting in. So it's really important, especially for anything going outdoors or into a dusty, dirty, or wet environment, like EV charging stations, smart city gear, kiosks. If the internal radiating element of the antenna gets covered in dust or water, then that will impact performance. There's no doubt about it. IP rating is the most often requested environmental specification that we get. And again, you can look out for this blue tag on the data sheet to find the official IP rating for the antenna that you're looking at. So here's a useful infographic, and it shows how ingress protection, how the rating system works. So the IP code is made up of two numbers. The first digit refers to protection against solid objects like dust or tools. The second digit refers to protection against liquids, mainly water. So for solids, the scale goes from 1 to 6. A rating of 1 means it's protected against large objects like a hand, and as the number goes up, the protection gets tighter, down to very small tools and then eventually to dust. A 6 means it's completely dust tight, no ingress at all. And for liquids, the scale goes from 1 to 9. A rating of 1 protects it against dripping water. The mid-range ratings kind of protect it against splashes and jets. And at the high end, ratings like 7 or 8 mean that the device can handle full immersion. And 9 adds protection from high pressure and high temperature jets, which is useful for harsh washdown environments. So here's an example of an IP-rated antenna, right? Our Oscar 40 Pro, which is designed for outdoor use, and it's rated IP67. So it's dust tight, and it can withstand temporary immersion in water for up to half an hour. And I just want to talk through how we actually verify that rating, because we don't just assume it will be fine. We put it through proper lab testing. So our IP tests are carried out by a company called MS Testing, which is a UCAS accredited lab here in the UK and in Durham. So it's not an in-house test, it's a third-party verified test, and it's done to the proper EN 60529 standard. So we test 2 samples, one for dust, one for water. For the dust test, they put the antenna in a sealed chamber and basically pull a vacuum inside the antenna enclosure and trying to suck in fine dust particles from the chamber. And they draw 80 times the volume of the antenna using a negative pressure pump. Then they crack open the enclosure, check for any dust ingress. So for the Oscar 40 Pro, you can see here from the picture, no dust ingress was found, so it passed. Then for the water, they submerge it in 1 meter deep tank for sort of 30 minutes. And once it's out, again, they open it up and inspect the inside. No water got in, so it passed. And then we get a full report a full report of the test, and an official certificate with a reference number showing that it passed, which we then publish on our website for anyone to check. So you can show that report to your customers, you can tell them that it's been third-party verified, and that gives them that assurance, that the antenna won't fail in real-world conditions. So IP testing isn't the only kind of environmental validation that we can do. There's things like vibration and shock for rail or heavy machinery, salt mist testing for marine and coastal environments, and extreme temperature and humidity cycling. Uh, Now, we don't do all of these tests by default, and there is a reason for that. If we ran every possible certification on every antenna, the cost would shoot up, and most of our customers don't need them. What we do instead is we handle these on a project by project basis. So if a customer says, hey, I've got a rail application and it needs vibration certification, then we can do it. Or we need salt mist compliance for something going on a ship, then we can customize a version of one of our off-the-shelf antennas, using a different radome, an adhesive, or a base. And then, we'll arrange to have it tested to the appropriate standard. We can even test the antenna alongside the customer's device if that's something they're interested in. So, there you have it. We've kind of checked off everything off the list, and now we have an antenna that perfectly fits the customer application. All that might be left to do is to make sure that the cable length is long enough and that the connector matches the port on the device, and we can arrange samples. And we try to offer you guys free of charge samples if it's 2 or 3 pieces. Maybe there might be a small charge if it's more. Now I've run over as usual, so apologies for that. But before I leave you, I want to signpost you towards some really useful web pages and tools on our website that can help you with antenna selection. So the first link here is just for our antenna catalog, which you can use to browse our entire range of antennas ordered by mounting type and ordered alphanumerically. And that's useful if you know which antenna you want and you just want to find the product page. So there's a link there above that you can use. The second one is our selector tool, which many of you will be familiar with, but we have streamlined it somewhat, and we have added the option to select from a range of different combination MIMO options, which will become more and more relevant as we're planning to release many more of these in the future. So I'm also looking to make improvements to this tool based on some of the feedback received from some of you, so look out for that in the future. But for those that aren't aware, you can use this tool to guide you through the antenna selection process. You select the mounting type, the technology, the IP rating, and if you need to, there's the option for multi-port technology as well. And that will return some relevant antennas to help narrow down your search. And now we also have, for cellular applications, a new selector tool for those customers that have a specific module, right? And they want to select the appropriate antenna just based on the list of supported cellular bands that module is designed for. So they simply input the bands shown on the data sheet into the selector tool. In this example here, we have the Quectel EC25. Then you choose the mounting type and it will return a list of suitable antennas that are optimized for those bands. So have a play around with that if you haven't already, and any feedback would be welcome. So for anyone that wants a deeper dive into the topic of RF antennas, we actually have a really great ebook that was written by our head of engineering, John Culver. And that covers many of the topics that we've discussed today, but in great detail. And it's very comprehensive. And if you can read this whole ebook, then you'll know everything you need to know about antennas. But it is 50 pages long, so I don't expect anyone to read the whole thing, only if you want to. And finally, I want to show you guys something that we've been developing, which is another tool that can help with promoting antenna sales. It's a new ruggedized sample case that you can take with you on customer visits and show off at trade fairs, and that contains a good representative selection of our antenna range with different shapes and sizes and mounting types. And you can open it up and display this infographic that you can see here on the right. And that shows like the whole IoT landscape and some of the different applications and end devices that our antennas are typically used for. So inside you'll find 3 trays that can be removed and displayed on stands and with a range of antennas and cables. And each one has a QR code that links directly to the data sheet to find out more about that particular antenna and how it performs overall. So right now we've made 2 of these cases that we made initially for our own sales team, but we're more than happy to lend them out for trade fairs or important customer meetings that you might have. And if you'd like one of your own as well, please let us know. We'd be glad to put one together for you with a custom design, maybe your logo alongside ours on the top, and even a selection of antennas that are tailored to your market or a specific industry focus, if you like. Now, if you want your own, there would be a small cost involved just to cover the materials and assembly. But this isn't something we're looking to profit from. We see it more as a shared marketing investment to support your sales efforts. And that's it. Many thanks everyone for attending. I hope you enjoyed. I hope you found it informative. There's a lot more to talk about when it comes to antennas. This is only a sort of entry-level selection guide, but if you're interested in other topics like typical use cases or maybe technical deep dives, or maybe you just like to, know more about specific Siretta antennas that we've released in the last couple of years, as well as what we have coming down the pipeline on our roadmap. Things like that, just let us know. We can do more of these webinars. And I believe someone will put a link in the chat or for a quick survey. Or you can scan this QR code on the screen. And if you wouldn't mind taking a few minutes to complete it, that would be very much appreciated. I can use whatever feedback you give me to tailor future webinars. So thanks again, everyone, and hope to see you all soon.